Hey kids. When we left off, we were talking about Newton and his laws of motion, our little introduction to forces. What I'd like to do is basically build on that, talk about a few different types of forces, and generally how we look at the forces that are acting on an object. So we're gonna just move away from this. We're gonna keep this in mind, right? But we're gonna move into a different part. Okay, well, I guess we'll go this way. We'll go this way. No, it doesn't really matter. It's gonna freak. Wait, it's not letting me. Why are you not letting me go in directions? Hello? Hello? Is that like the very? Am I in the wrong? Should I go literally any other way? This is all the stuff we've done so far, by the way. What if I do this? What if I just take all of this? Hello? Oh, it's thinking. It's thinking about that. Didn't really. Can I just move all this way? Are we okay with that? We are? So I can work down here now? Cool. Good enough. Okay. That's more difficult than it should have been. Now, if we're looking at this, so let's call it forces continued, right? There are three-ish kind of like big time forces that we'll talk about, and then there will be other, I hate to say leftover, but like leftover forces that we'll talk about later too. But our big types of forces, the biggest force, the easiest force to label on onto an object. I can do better. Force of gravity, or F with a subscript G, also known as an object's weight. So like the weight of an object is the force of gravity acting on that object. Your weight on Earth is equal to what is the force of gravity acting on you on Earth. Which should kind of make sense. Now your weight is something that will change based on what planet you're on. Alright, obviously because we do things on Earth, basically the same thing. The big deal to keep in mind for all of these is that F equals m times a. So here, let me do it this way. The force of gravity is F with a subscript G. It equals m times G. Equals mass, your mass, times G, the acceleration due to gravity. Or for you, it would be m, your mass times gravity, the acceleration. For any object, it's its mass times the acceleration due to gravity. Right. The next force that I want to kind of mention. Ooh, actually no. Hang on, let me do a slightly different order. Next force I want to mention is something called the normal force. Right. Now this, and it's labeled with an F with a subscript N. N for normal. Right. This is the force exerted on an object. That's not how you spell object. By a surface. So your object has to be resting on a surface, whether horizontal, vertical, at some kind of slant. It is always perpendicular to the surface. Right? And what that means is that if I have, right, let's say a box sitting on a table, right, and I'm just going to simplify it down to this. It means that there would be a force from the table acting on the box like this, and I would call it Fn, the normal force. Alternatively, if you have an object on a hill, right, then the normal force would, okay, let's do better. Start from the surface and go as perpendicular as I can, so, oh jeez. Again, I just want to emphasize it's the big deal that I want to mention is that it's perpendicular to the surface. It doesn't just always point straight up. Right? Or let's say that you are, like this. This would be the normal force. It's always perpendicular to the surface. That's important. Right? And the third big time force is the force of friction. Oh, that's not how you spell friction. It's not a C. Let's do better. Alright, force of friction, which is an F with a subscript F. Right, it has its own equation, which we'll get into. I'll do it during class. I'll do it like during class. I know this is like a before class thing. This is the force that opposes motion. So points opposite of the direction of motion. So whichever way your object is going, force of friction is going to point the other way. All right? Now with these forces, right, the force of gravity, the normal force, the force of friction, what we like to do is we like to create what we call free body diagrams. Again, let me do better here. Okay, and what a free body diagram, or what free body diagrams do, it shows all forces acting on an object. All the forces acting on an object is what we call the net force. And if you remember from the reference table, the Newton's second law equation looks like this. It looks like acceleration is F net divided by the mass. Right, so this net force is all the forces acting on the object. That's the net anything is the total of all of those things. So the net force is the total force. A free body diagram shows all the forces acting on an object. So, example, a book is at rest on a flat table. And again, I'm just going to do the simplest version of this right now. And we'll talk about more examples. I'll have you do a few simple and straightforward ones before we get into class. So here's the table. Sure, it's a book. Now, I would have the easy one that you can pretty much always label is the force of gravity. And there will also be, because it's resting on a surface, there will be a normal force. There are no horizontal forces acting on it because it's just at rest on the table. The interesting thing here, you should kind of recognize that, and we'll talk about this in class too, because it is at rest, the normal force equals the force of gravity. They should be equal to each other, all right? Now again, we'll get into that. We'll get into a lot of things between the next class and the next few days. But yeah, I just wanted to again, very quick intro. There are, a few forces that we will be talking about. The force of gravity, the normal force, and the force of friction are the big ones. How to represent them, kind of what they mean, basic definitions, and what are free body diagrams? How are we going to use them, all right? look for a quick assignment, like 5 questions, maybe 10. Same idea, multiple choice and short answer that will look like what you will see on quizzes and tests. Give that a shot, and I will see you next time we're in class. Take care, kids.